Hello everyone, I am Kushala Ji, studying in 8th semester ACE of Sri Venkateswara College of Engineering, Bengaluru. Today I am here to give you all an idea about a deployment model for IoT devices based on fog computing. These are the contents which I am going to discuss in the upcoming slides, starting off with the introduction, followed by brief extensive literature review, objectives, advantages and disadvantages, proposed methodology, results and discussion, conclusion, and references. Now, coming to the introduction part, we know that cloud computing is a massive amount of dynamic and distributed resources that are delivered based on requests to the clients over the internet. Many centralized cloud computing models may have difficulty dealing with challenges caused by IoT applications such as latency, network failure, and capacity constraints. One of the introduced methods to solve these challenges is fog computing, which makes the cloud closer to IoT devices. A system for dynamic congestion management brokerage is being proposed. In addition, a forwarding policy is introduced which helps the cloud service broker to select and forward the high priority requests to the appropriate cloud resources from fog brokers as well as cloud users. After integrating fog computing technology into IoT applications, the system can respond in milliseconds. Fog computing and IoT are two well-known information and communication technology that have gained popularity in the recent years. Fog computing can be seen as an extension of cloud computing to the edge of the network, where the data is being processed near the source instead of being sent to the cloud directly. With the increasing abundance of sensors, more and more data is being generated. Hence, use of fog enables applications and services to act before they are sent to the cloud, especially when it comes to data analysis and management. Fog as a service is a new class of service. Here, service providers create arrays of fog nodes across many geographical areas, which act as ownerless resources that can be rented by businesses from many different industries. Every fog node has local computation, storage, as well as networking capabilities, making it an ideal solution for distributed data processing and analysis. Fog as a service affords a new method for businesses to offer services to clients. Rather than the large companies that typically operate clouds at different scales, Fog as a service provides public as well as private computing, control, and storage services to both large and small businesses. As a result, they can meet the needs of a wide range of clients. The below figure represents the working of fog computing. Now moving on to extensive literature review. In this section, we will discuss the most popular models for cloud and fog computing along with their pros and cons. I have referred to these three main papers regarding fog computing. The first author, Walid Nouri Hussain, in the year 2023 published a paper named as A Deployment Model for IoT Devices Based on Fog Computing for Data Management and Analysis. The pros of the system were system response is provided in milliseconds and fog computing allows company to work with both secure and open data, which is very beneficial for the business. The cons were downtime and technical issues as well as interrupts in the network may occur for any reason in any internet based system and makes the customer suffer from outrage. The second author is Peter N. in the year 2022 published a paper named as Fog Computing and its Real-Time Applications. The pros were fog computing is capable of running and managing big data that is generated by Internet of Devices. And fog computing can also solve problems of latency as well as overcrowding. The cons were limited scalability and additional expenses as companies should buy edge devices like hubs, routers, and gateways. The third author was Hong K. In the year 2021, published a paper named as Mobile Fog Programming Model for Large-Scale Applications on Internet of Things. The pros and cons are as mentioned below. Now moving on to the objectives. The main objectives of the proposed system is to comprehend the fog computing based on distribution strategy for IoT devices for a sophisticated broker management system, to design and evaluate the architecture of dynamic congestion management system, cloud service broker, as well as dynamic congestion management brokering system which contains foundation for fog. And the third objective is to lower the total system reaction time to a few milliseconds by incorporating fog computing technology in IoT apps. And the fourth objective is to get rid of issues like network failure, delay, and capacity limitations brought on by the use of conventional processing in IoT apps. Now, as we can see, this slide is about advantages and disadvantages. The major advantages of fog computing are as follows. It minimizes the volume of data delivered to the cloud, reduces network bandwidth usage, increases security by keeping data near to the edge. Mobility is also being supported. It reduces latency and the system response is fast. There are few disadvantages of fog computing as well. The cloud's anytime, anywhere, and any data benefit is diminished by physical location. Man-in-the-middle attacks and spoofing of IP addresses are some of the security concerns. Now moving on to the most interesting part, that is the methodology. As we can observe in the figure, it describes the architecture of dynamic congestion management brokering system. This gives us the detailed view of the proposed system, and it has been categorized into 4 parts. The first part is the cloud users, and the second part will be cloud service broker, and the third part is fog service broker, and the fourth part is cloud service providers. The fourth part's description is as follows. Part 1, cloud service users. Each client is assigned a local representative by this area who then ranks each client's requirements and forwards the most urgent demands to the CSP. Job parameters such as the kind of VM, necessary software and hardware needs are included in this user queries. Part 2 is the CSP, Cloud Service Broker. The cloud core is considered in this section, and the classifier will handle the entry queries using FIFO method if the CSP is not overloaded. The WFQ method is being used in order to reduce overcrowding. Part 3 is the FSP. This part describes the high degree of edge fog and IoT connectivity as well as their interactions with the cloud. The fog gateway offers user interfaces for software that enables user to control IoT devices and the service expectations. Part 4 is the CSP. The tools, both virtual as well as real, are covered in this part, like CPU, storage, RAM, bandwidth, etc. It is responsible for monitoring how cloud service companies handle tasks. Now coming to the results and discussions part. There are mainly 2 simulators, namely iFogSim and CloudSim, which are used in order to evaluate the effectiveness of the proposed system. iFogSim is used for replicating environments in which fog computing is being used, and CloudSim is used for simulating environments in which cloud computing is being used. The performance of fog computing model is evaluated mainly based on 2 categories. Moving on to section 1. In this section, while one user sent the cloud 100 tasks to FSP, 4 users in the cloud collectively sent 500 jobs to CSP. At this stage, there was no precedence established. Rather, the CSP accepted and processed the requests in FIFO fashion. Figure 1a illustrates the amount of time spent completing the simulation described in first section, whereas figure 1b shows the task that could not be completed. Now moving on to the section 2. In this section, 500 additional jobs were provided by the same source to the CSP, but this time the FSP gave its customers tasks a high precedence, that is the paid service. Other cloud users continued to receive priority as normal, and the FSB successfully finished all the tasks for user 5, highlighting the advantages of the priority service applied. The working time was also considerably less compared to the section 1. Figures 2A and 2B shows the working time and refuse tasks respectively. With the help of these two sections, we can conclude that the processing time of different jobs using 5 different users incorporating fog computing was considerably less. Finally, I would like to conclude that IoT solutions can be handled before being sent to the cloud using fog computing and IoT devices. Data analysis at the processor edge is enabled by data security verification before the cloud transfer. We can overcome many difficulties caused due to IoT applications such as congestion, delay, and network failure using this model. And by incorporating fog computing in IoT devices, the system response time is reduced to few milliseconds. However, a large number of cloud requesters from the fog broker layer can overburden latent resources and lower the QoS if sensitive data needs to be transferred to the cloud quickly. So a limited number of requests are being preferred. These are the references which I have been referred to. So yeah, thank you. Hope you all liked it, and thank you all for spending time on watching this video. I think I've shared useful information about fog computing. Thank you once again. Have a great day.